Well, hi, and welcome to my shop, and thank you for joining me here on April 5th for something I've never done before, a radio unveiling. Have a look at this. Wow! Holy smokes! Look at that thing. Oh my. Look at the condition of this radio. First of all, the first thing I thought when I saw it was it's an imitation. Oh no, it's not an imitation. This is a radio out of the 40s or something like that. 40s or maybe 50s, I'm not sure yet. Isn't it fantastic? This cabinet is fantastic. Look at that. So I believe this cabinet is a type of plastic called Catalin, but I could be wrong about that. Fantastic yellow color. Now, the owner told me originally this wouldn't have been yellow. It would have been perhaps beige or whitish. And it's turned this color over time, which is really great, because I mean, if that's really the case, it's fantastic. Even the knobs changed. I gotta kind of wonder about that, but nevertheless, wow, fantastic. This is all in beautiful shape. Okay, so it looks like a cat got added here maybe a little bit, but that's hardly noticeable. Cabinet is in beautiful shape. You know, I don't like this when I get radios like this, not very often, especially like this one. Makes me nervous trying to fix something up that looks so great already. Not so sure about how well it operates. Let's look at the back here. Look at that. You'd swear that maybe this spent a long time in a box somewhere or something. How did it end up in this kind of condition? It's fantastic. I can point out a couple things right away. The screw type here, and here are different. There are 3 different screws. And there's a screw down here, and it's ripped out. So the different screws, you gotta wonder about that. Oddly enough, it's got a switch back here. Not sure what that's about. And somebody took the time to wrap up the antenna wire in tin foil. No, this is not a good idea at all. This is counterproductive. Let's get this out of here. I'm not exactly sure why they thought this would help the situation. What do we got here? We haven't got much of anything. There we are. So it's come with just a little bundle of wire here. Could be a lot of it is missing. It's bared here and there. So this is really, that's bad. We don't want a wire antenna. We want a loop antenna on these radios. The impression I got is this is it. This is the antenna. A piece of wire. Emerson Equipment Television. I can't read it. Emerson Radio and Phonograph Corporation, New York, USA. Is this the model number? AU190 must be the model number. Yeah, down here is AU again. AU with some other number. 148408-4. Okay, power cord. Let's take a look at it here. Pretty long power cord. And we have a polarized plug on it. And so this is almost certainly a replacement cord. Somebody's been at it. We know somebody's been at it. There's no way a radio makes it this far into the future. How tight are these? Now, you would never want to put these screws in tight, especially if these are kind of random screws, because you know it puts a tension on the plastic, right? It puts a force pulling it apart, and plastic's often not very good in that situation. Nothing much is really. Tension is a big problem. Compression, fine. Lots of stuff does fine in compression, but so you could easily put a screw in like this, and in the process you could crack the. There we're coming out like that. Crack these fittings here where they have a little more plastic to put the screw in. 1, 2, 3, 4. Five tubes all packed in here, and you'd think this would generate a lot of heat. I mean, it would generate a lot of heat. And put the same screws back into the same spots. Now, surprisingly, too, these plastic cabinets often, these hard ones, and Bakelite, same thing, they'll thread this with a machine thread, not a wood screw. So if you grab thinking, oh, I'll put a wood screw in here, wood screws drill in and force out, whereas machine screws are basically the same diameter all the way. You put in the wood screw, as you put in, it's putting that tension and maybe crack along here. What a shame. We don't want that to happen. Okay, well, I can see a new part sitting right here. I can see a new part sitting here, and looks like one here too. So the radio's been worked on. I think we need to take it out of the cabinet though before I try powering it up. We'll pull the knobs off. Okie dokie. Now so it would appear these are the screws here. They're the original feet. This one's loose here. They look like they're the original feet. There's cloth on here. It looks like the head is spinning on the threaded shaft. So I'm turning this, I'm not turning the shaft, I'm not getting it out. Oh, this is already, what, come on, already? You're going to do this? Wow, this one's quite tight. There we go. Same thing here. Feels like the foot is spinning on the shaft. Let's take a closer look here before I don't want to get myself in trouble already. Well, no nut there. What about way back? No nut back there either. Down here. Well, there's no nuts. That front screw doesn't even look like it's going through the metal. Just the way it looks. Well, how am I going to get these out of here? Oh my gosh. We're already in trouble here. Is it turning? Yeah. So that's me turning the foot, but the, it's not even wiggling. That has to be the screw though. Oh yeah, there it's wiggling now. Well, maybe if I can put tension on here, I can make it grip the screw. Oh, come on, focus. Nope. Hey, it's going there. So what I'm doing is I'm shaking it like this. big darn camera. Come on. Well, that's what's going to take to get the so I'm going to work away and get these feet off of here, and we'll get the radio out and examine it. Well, I got one out, but the others are impossible. So I took a look at the one, and yeah, you can see in the camera there's a flathead screw in there, or a flathead. Yeah. So that's how this was done. So, okay. When you know how to do it, it's easy. Okay, back to taking this out. Okay, got the screws out. Once the secret was known. Now, I'm pretty sure the speaker's coming with the radio. Here we go. Easy as can be. No complications. Okay, let's take a look at the cabinet here. When you look inside, it's starting to reveal its age inside, isn't it? It's heavy glue up in here, hot glue. Somebody's hot glued this all. They've tried, I think, to kind of stabilize this with glue everywhere. Glue all up through here. There's nothing written inside anywhere. There's no cracks, although you can see this would be a manufacturing defect, I think, the way this looks through here. The outside's beautifully smooth, but the inside is not. So the outside must get some kind of treatment, I guess, to make it like that. Just the mold. Okay, nothing underneath. Okay, I'm going to put this where it can't get damaged. And what do we got here? So, something odd here. Something very odd. This is very odd. This is extremely odd what's here. Somebody's soldered. Wow, okay, so that's really strange. Same thing on the other side. They've soldered a diode. What looks to me like a diode across here. Why the heck would they ever do that? So a radio like this, usually the light is powered from a tap on the heater filament, because there's no transformer in here. So there's no easy way to get 6 volts. I see the speaker's been repaired here too. I'm just moving it gently, listening and feeling for scraping in here. There's none. Let's take a closer look at these diodes, or what I think are diodes. I mean, what else could they be? Well, what else would somebody put there? This has to be a diode, eh? It doesn't have the diode marking on it. 8 something. What's this one show? 5A. It looks like 5 amps. But usually diodes have a black band on one end. It kind of, but it certainly looks like a diode. Why would it be there? Why would somebody do that? They think they're cutting the voltage down or something, or they put in incorrect light bulbs and this is the compensation for it, but this doesn't make sense. So just look really carefully. They've done it. There's the lead wire down here. This wire here coming along, and they've simply put it just paralleled it across the light. I don't know what they're trying to do there. That's a mystery. Take a look at this dial. This dial is really fancy. We didn't look at it when it was outside. Well, those look like they're practically like pieces of plastic, the numbers in that placed on top of the surface behind. The surface is, oh, it looks like stamped copper. And there's some kind of plastic coating here, cover on this. Yeah, this is probably how they've snapped the plastic onto the very fancy stamped, what I assume is a copper sheet. That's really got a look to it. Eh? They really, even this piece, instead of making it round, they've made it hexagonal here. Emerson Radio New York. Now this is so low in the radio, it's hard to see it. Well, it really looks like plastic letters on the surface. It is, for sure. I can see shadows. Well, this gives it a very, very particular look, but you have to get up pretty close to see that. USA. Amateur. Whoa, is this a two-bander? This is a two-band radio. I didn't even realize it. That's why it has a wire antenna. You can't do shortwave with a loop. Well, maybe you can, but mostly shortwave is done with a just a wire going out the back. Well, it's a very, doesn't go, oh, this is really quite surprising. It only goes up to 4 megahertz. The international broadcast band really gets going at 5 and above. There's one shortwave station down around here somewhere, a bit of ham radio. This would have been called the police band in the early days. Oh, police. Well, it's a really cool dial. They really went to town on this. Sort of looks like a, I don't know, a sunrise would it be? Let me focus that and get a look at the whole thing. Here. It's really lovely. I think, maybe the light casting, you see how the lights are positioned. So they're casting light, this, down over it. It's going to make all this pattern in the copper really stand out. Very nice. Okay, a little closer look at the speaker. And while I've got the close-up camera, we might as well have a look at... no, I think that's still solid. Might as well have a look at the radio with this close-up camera here. Well, we better start with the far camera, otherwise you can't relate. Cannot relate. Yeah, let's do this. Okay, so this is an old enough radio that it does not have a permanent magnet speaker, and instead is using a coil. That's the coil right there. Electromagnetic coil to make the magnetism for the speaker to operate. The speaker is a very old style. This radio I think is older than I would have guessed. I think. This cover is a sign of it being fairly old too. I think you could what you could imagine about this is the radio manufacturers, the tube manufacturers, were doing what they could to reduce the cost of their products and the sub-products, the radios themselves, and they eventually got away from having to put these covers on tubes, mostly by developing the metal tube, which I thought I had one in my hand here, but I don't. Yeah, here's one. Yeah, developing the metal tube. Well, that's metal. But underneath it is a glass tube. I think if we were to pop this off, and I could be wrong about that, but I believe that's what it is. The part that's holding the vacuum is a glass tube still, not this metal. But I think there might be some that are actually metal. I don't know. I'm not sure. 12SQ7. This is also, you can tell this is an earlier radio by the fact that it has grid caps on top of the tubes. That was another thing they wanted to get rid of, and eventually they did. So that one of these tubes could easily be a 6K7. 6K7, a 3-letter designation from the early 30s. Well, then when they reproduced this tube with the same kind of function, but with this cap now just a pin underneath, no longer a cap on the top, they added another letter. So 6K7 became 6SK7, and the S being single-ended. So when you're looking at a radio, if you see three-letter designations, you can kind of guess it's this vintage. It's getting a little old. Whereas if you see SK, SQ, that S means there's no caps up here, and it's a little bit newer. Rectifier tube is a little odd too, because it's not in a like the shape of this glass tube is a little bit odd. Is that some odd tube in there? What is that? Wow. Here's another sign that it's a pretty old radio. So there's no center pin on this tube. So this is a 6-pin tube. 2 pins are fat. These 2 pins are a little fatter than the rest. Hard to see. There's an arrow. Can you see the arrow down in there? The arrow is also helping you locate these 2 fat pins, which need to go into the socket where there's 2 large holes to receive it. This has got the tube type written right on it. 25Z6. It's written right on the ring there. 25Z6? No, Z5. 25Z5. I've never held one of those tubes before. There we are. 25Z5. See how nice and clean it is too? Someone has cleaned these tubes up, because they wouldn't be this clean on their own. Okay, let me put that back in. Okay, let's look underneath. Now, I think I can tip the radio forward this way. Tip it on its back. The antenna here is going to give out very soon. In fact, it's all... Oh, it's caught the cord here. Let's tip it this way. Ooh, how do you get the parts in there? Ooh. I'm going to tip it on its front. Oh, how do you get in there and do stuff? So I see a part changed here, part changed here, here. Oh, this one's just kind of floating here. Another part over this way. So someone's come in and they've done the capacitors. Let me get my other camera going again here. Looks like they've done some stuff. So this is probably the filter capacitor here. What value is that? Where's the value written? Am I blind or something? Huh. Okay, well, here's another one up here. Maybe we can see it up here better. It's probably just, yeah, this one. Yeah, 22. 160 volt, 22. That's just what you would kind of expect to find in here. See, the one end is just floating on the wire. What's that? That is a whopper of a solder connection. Somebody's done a ready to carry 50 amps on that solder connection. Look at these are all heavily soldered. He's a better solderer than me. Yeah, I think whoever did this knew what they were doing. I don't think this was the first radio, but this is a tough one to work on, trying to get in here. There's a resistor right there. So that thing mounted on the bottom there is a resistor. mounted to the sidewall of the radio to conduct the heat away from it. Yeah, the person who's worked on this radio has used a very, very strong soldering technique. You really see it clearly here. Well, maybe not so clearly there. Maybe here. Well, I guess he's done different things at different times, but in some cases, like this one, right here, it looks like he's twisted the lead wire into basically a coil, then slid it over the other wire, and then soldered that up. Which I would be inclined to crush it myself, but what's that thing? So I think that's a capacitor. No, that's a resistor. So stuff connected right to the chassis. Yeah, let's just see what's going on here. So you see shield soldered right to the chassis. One of these connections, this one here, goes right to the chassis. Black wire from here comes into this bundle, and there's a black wire comes up to the other capacitor up here, and that's the negative, and that's the positive there. Probably between these two filter capacitors would be the field coil of the speaker. Somehow. Notice the capacitor has two distinctly different sizes of plates. The smaller plates would be the local oscillator plates. And some adjusting trimmers there. These two screws. There's the switch I was moving on the back here. It's only got two terminals. I think this is a tone switch. I guess you don't adjust. You adjust the tone once, I guess, is their thinking. Oh, here's another trimmer sticking out here. Right in the coil right behind it. There's a big old questionable capacitor right there. This could be mica, maybe not. Who made it? I don't know. There's another one here. That's the back side of it there. These might not be mica capacitors. These great big ones here. They might have paper inside them. What else do we see here? Well, I don't see any wax capacitors, so I think what's happened is my predecessor has done the hard work and replaced them. Way down there. Wow, how did he get in there? Look where this is. It's way back in there. But he did them. Offhand, no reason for me offhand to think something's wrong here. In fact, quite the opposite. Somebody's taken the care to do the work. How come they didn't replace this piece of ratty old antenna wire? But they didn't. The antenna wire is very close to shorting. If this wasn't grommeted, it would be shorting on the chassis, and I don't think it would work very well after that. I think we got to start this guy up. See what he does. I think so. So let me tip him, stand him back up. I do like to operate radios before working on them if it looks in any way reasonable to operate them. This one certainly looks reasonable. Mysterious. Lights are very mysterious to me. What's going on there? Okay. Coffee break time though. Okay, I think we're ready for a try here. A little practice. This is on and off. This is the tuning. This must be the band. So we'll imagine we're starting with the broadcast band. The antenna still amounts to this nothingness here. So chances are, if it picks up anything, it's just going to be noise, not much more. We will see. Eventually I can connect that antenna to an outdoor antenna, and maybe then the radio will start actually receiving stuff. Okay, so currently switch is off. So the first thing we're checking is, does the off switch turn it off? So I'm going to apply power. There we go. Nothing happening. That's perfect. That's kind of what we want. 110, that's a little low. So if I operate the radio on full voltage, it's going to get 116 volts, but I'm going to be running it through these dim lights. In fact, we're going to run it through just one of them to start. So just this light. That's going to really restrict the voltage. Power off, switch on, volume up just a little bit. Okay, here we go. So, watching the dim bulb, bright, kind of a bright, kind of down to a certain level. It's just sitting there. Lights are on, pretty dull. Is it these things? What was somebody doing here with that? Okay, now you see the lights are fairly bright. 81 volts on the radio. Some radios would operate with that. Anything really bad happening? Let's wait and see if we get some hums out of this. Nobody home. So what I'm going to do is I'm going to screw in the other light bulb. That's going to jack the voltage way up. It's going to go up to almost normal. So it's only 82. That's pretty low. Here we go. The lights look unusually bright. In fact, they don't look right to me. They look too bright. This is 100 volts now. Something definitely a little weird going on here. Maybe these lights get their voltage through a different method in this radio. I'm not familiar with the rectifier there. We'll check it out in a bit. I'm going to measure the voltage. Assume it's an alternating current. And it might be more than 6 volts. There we go. Volts, and they're that bright. Radio's making sound. 3 volts. Okay, don't know what to say about that. That's very odd. More volume. Volume full. I'm going to grab the antenna, put my hand near it. See, listen, not doing anything. I would expect some kind of noise or something to come through at that point. The noise we're hearing is not really affected by the volume control. We'll change bands. Ooh, that changed. The band switch may be the problem here. Okay, so what we're going to do next, we're running with 97 volts. Drawing a fair bit of power. 98 should be enough to make it operate. Okay, we're going to inject some signals here. I'll turn the volume down. Quiet. So this should cause a loud noise, hum, buzz to come out of the speaker. Well, that means something is broken down after these stages. These are earlier stages. forget the rectifier tube. That's the output tube. That's probably the, I can see the Q here, 6Q7, mixer tube, IF amplifier tube. Did I say mixer tube? Detector tube, IF amplifier tube, mixer tube, all covered up here. Nobody working though. And no effect from the antenna. In a radio, any radio, if I can get it to the point where just doing this makes some kind of effect, I'm ready to go. But like this, you have no idea what's wrong with this radio here. I mean, there could be 2, 3 things wrong. We don't know. We don't know anything right now. We know nothing except nothing comes out of the speaker even when you do this. Oh. That's a little bit. So this is probably the grid cap to the triode amplifier that's in this tube. And the signal being amplified by this tube is being fed to the output tube and onto the speaker. If I touch the grid of this tube, we should get a loud response. We get something. So that's suggesting things are working past here. The audio stages appear to be working. The volume control should have no bearing. And it does. Okay, so much for what I said. Probably this radio, the first step is to verify that these tubes are functioning properly. That's probably the first step. Because someone's already done the work. Okay, that's what's next on the list. Are the tubes any good? We will find out. Okay, here we go. I've got the 25L6 here. 25L6, and I've set the machine up for a 25L6, so it's 27.5, 8 on the signal level, 18H for bias, 27345, 27345, 0610, 0610, 43, C. Okay, that's good. Pop them in. Okay, first thing is to look for shorts, and let's see what happens here. So it's popped up a little bit on setting number 1. So this meter will give you actually a resistance reading, and it's suggesting there's a leak here of around 5, say 4 megohms, something like that. Believe it? It's very stable. I'm just watching the pointer to see if it's moving at all. It's not. Okay, so a tube with a leak in it, a short rather, should not be tested in a tester like this. I don't think that's enough to worry about. So we're going to give it a shot here. This tube should show just over 1,000. There's the 1,000 mark right there. Should go just over it. So it goes well over it. Pointer's actually drifting downwards. I'm not sure how to interpret that. Okay, well, I don't think this tube can be responsible for the radio not producing anything. In fact, when you think about it, the radio did produce a little bit of noise, suggesting the audio circuits were doing their thing. And I'm just getting the next tube out here. So that kind of suggests, I've got this light shining in my face. that the problem is earlier in the radio. If the radio could produce the audio at this point, we would hear it. That's kind of what it seems like. Oh, this is too big a screwdriver. You can hear my tool rack in the microphone because I have a microphone right over here. And it happens to be touching the tool rack, so as I fiddle around you can hear all that rumbling. Okay, let's take this off. These tubes with top caps on them, you need to be a little careful taking the cap off the top that you don't loosen this. This metal part is just glued to the top. There's a wire that's going through the glass down into the tube to connect to the grid. And if you just twist it, a lot of tubes are like that. The cap comes loose, and then the only thing holding it is that wire. So checking the type here, 6Q7, no question. Okay, let's bring it over here. 6Q7. QRS, 6Q7 right there. Two tests in this. So first thing, 6.3 volts for the filament. Signal level is only 1. Bias is low 23. I think that's what L and H stand for in the bias, low and high. 27300, 27300, 0610, 610, 30 over here, F. Grid cap. And their grid cap. Okay. No leak showing up. So this tube should read 780, which is about here. Oh my. That's bad. Let's double check everything. 6Q7, 6.3, right, and it's warmed up. 1, 23L, 27300, 27300, 0610, 30 F. Now it works. So what happened there? Could be the switch. The switch is a little dirty sometimes. I think it's not working. Okay, well, we're way above 780. So the tube tests good. Now there's another part to this tube. There's a diode part. I'm going to pull it out of the socket. Some tube testers you can change all the settings. As long as you don't hold down the test button, you can change all the settings. But in others, if you change the settings, you're doing stuff with the tube live. You can't have the tube in while you're doing the settings. I don't know about this one. I can't remember. 2703P. 2703P. 0610, 48 A. P1 and P2. These are the plate 1, plate 2. Put them back in. Don't think it really needs the grid cap anymore, but that's okay. So now we're testing diodes in this tube. These diodes are used to rectify the RF radio signal that the radio has amplified and produced. And once the RF signals, the IF output signal, the RF signal is rectified, the audio becomes discernible and can be utilized in the radio. Obviously amplified again and then sent off to the speaker. Okay, looking. Oh, well, that might be a normal thing. Sometimes there's a note here. There's no note. That looks pretty serious to me. My switch is a little dirty over here, it seems. That does look like a breakdown sort of thing, doesn't it, the way it's jumping around? Is it because the... No. Made it better. Made it worse. I think this tube's in trouble. Don't think I should push the test button on it with it like this. Would that make the radio quiet? I just don't think this would make the radio quiet. It is possible to know if I look in the book what number 5 really means. A leak between what and what. And I can't find my book. Oh, look at it. You see it just go wild there. Looked like it almost like burned off in there. Boy, you'd think it's something like this in the radio, you'd hear all this jumping around stuff. Now it's all settled down. So you could picture the elements inside the tube. The different metal parts are expanding as they heat up, and perhaps they just expanded enough that whatever was touching or getting close isn't anymore. We are talking about microscopic distances here. Not completely gone. She's all good now. Whatever it was has actually completely disappeared at this point. So we can test the tube now, I think, with this sitting like that. So put it on test. It's a diode test. Diode, all it's got to do is come up above where my finger is, which it did. Plate 2, way up. So other than this weird short thing, which appears to be gone now, it's not a hard over short either. It is some kind of a leak over a surface or something. Huh. Okay, can't say I've ever had a tube do exactly what this one just did. Put that back in the radio. See if the radio works now. I can't imagine this is the... No, let's carry on. Okay, so we'll just make a note. Make a note. Detector tube, questionable. Where'd my screwdriver go? Let's use this one here. A7. Oh, not quite what I was expecting. You know, there's only one IF can in here. Okay, 6A7. A7, there it is. 6.3, signal level 1, 27L, 273, I'm sorry, 73445. 7, 3, 4, 4, 5. 1600. 30. I don't know. Do I need to double check this stuff? Because you're watching me do it. I gotta double check it. 6A7, 6.3, 1, 27L. 27L. I don't think precision is that critical there. 73445. 73445. 1600. 1600. 30. C. Grid cap hole tube. Oh. It's an old tube. Grid cap. Takes the big size. It's got a small size and a big size. Takes the big size. Okay, let's see what happens with this one. Yeah, it's heating up. No shorts appearing. This tube should show 750. Should come up to about here. 750. It's right over. Okay, I think there's a problem here. I'm only left with one tube. Now that tube is armored. It's an armored up tube. It's a funny combination of 6 or 8 pin tubes. This one has 7 pins. 1, 2, 3, 4, 5, 6, 7. 7. Okay. No arrow. Wow. Looks like it's probably these two. Oh, there is an arrow. Yes, there is. Oh, there's nothing in the socket to really make the big pin stand out. There we go. Now this last tube is, as I said, it's armored. So take the cap off here. So even cover it right over completely. There's the wire coming up out of the transformer here. Take that off. Now I can leave the tube in its cover if I'm lucky. We'll see if I can get it out with the cover. Wow, this is not easy. The cover is jammed down into this sort of receptacle part here, and the idea there is that this is making electrical contact with the chassis. Oh God! It's another 6-pin tube. This will probably just kind of fall off at this point. Yeah, it fell off. 6D6. Okay. Let's head to the tester. D6. So these 3-letter tubes, they are scarce now, and getting just more scarce all the time. So these are not cheap. 6D6. There it is. 6D6. 6.3 filament volts, 2 signal level, 30 L for the bias setting. And the numbers are 73421. Check your tickets. 73421. 6000. 6000. 35 in the dark here, and F. Very important to get this correct. Okay. Double check. 6.3, 2, 30L, 73421. 73421. 6,000. 35. Okay, we're good. We're good to go. Where's this guy go? Is he going here? Yes, he goes in there. Big cap. There was a changeover in tubes in the mid-30s or so, where this kind of tube without the octal base with the center post on it faded away and was replaced by updated tubes, smaller tubes, cheaper tubes. I bet you they were cheaper to make. And these guys disappeared about mid-30s. They didn't disappear, but they were no longer coming out in new equipment, something like that. Okay, shorts. None showing up at all. This tube under this test should give just above the 1,000 mark here. The minimum. This is those values are minimum values. Well, it's way above. It's well above. So what do we found? We found one tube, kind of weird. Not sure I need to even test the test the rectifier tube. If you don't put these shields on, see the sticker here? Oh, you can't see the sticker. Now you can see it. See the sticker? So this is at a time where people had become quite concerned that the tubes they were buying were crap. And they buy a tube and it only lasts a month. They take it back. They say, hey, you sold me this tube, it only lasts a month. He goes, I don't know, did I tell you that a month ago? I think I sold that to you 6 months ago. No, you sold it to me a month ago. So to sort that out, they put a sticker on, and then the guy would write right on it, sold on so-and-so date. And then he'd sell the tube. And then, if it didn't last, you could come back and go, hey, look at this tube didn't last. And I get maybe prorated, or I don't know what they would do with that. Would give you another tube, I don't know. But that's what those stickers are for. And so that's really a flag saying this is back when tubes were not really all that reliable. This is a complicated tube too. It's got a lot of grids in it, I think. Kenrad. It's not a common manufacturing name. Made in the USA. Right on the socket it says 6D6. So yeah, and if you operate this radio without these covers, signals will come out of the radio and signals out of the tube, and signals will go into the tube, and you could easily get a situation where you get feedback, oscillation, and a mess. You can get a mess. It's got some ribbed for your no. Okay, looks like the big pins are here. Did I get it? I don't think I got it. There we go. It's down there, I think. Yep, that's down. And back on. Well, we don't have any good explanation for why the radio's not producing any output. I think I'm going to leave it at there for today, and tomorrow we can start looking more at why isn't this radio working. See if we can find out why. And until either I know what's gone wrong with it, or I get it working to some degree, maybe making one or two, repairs to it. Until then, I'm really reticent to work on the radio generally, because you don't know what's happening to it while you're working on it. So thanks a lot for watching, and tomorrow we'll go we'll dig a little deeper into this radio. See ya.